Hmm. And welcome to this video where we will be today looking into information flow models, the basis of which we have already covered in the last section in terms of what we know as a ladies best model or the models that help communicate data across different subjects and objects. This is a very highly testable concept in the exam, so you have to be very dead clear about the concepts here. And it may get very confusing with the names that has been used, but that is something you must memorize either by making post-its or flip cards or any other way which is working for you to memorize things. The first and the most important information flow model is called Bell-LaPadula. The name is a bit of a tongue twister. And the main purpose of this model is to take care of confidentiality. Uh, it is implemented uh, through the working model as we have seen before. It's called mandatory access control, which is driven by the configuration of subject and object. And it has three important properties that you must be aware of. The first one is called as the simple security property SS, which entails that there is no read up of the data for a given subject on a given object. Now, it is to say that the subject with a secret clearance can't read top secret data. And the idea here is that even if you have a higher level access to data, there will always be a data which is above your access, which you should not read. Take it for example that a manager in an organization can check the salary details or the working address of all the employees reporting to him or her, but the same manager will not be able to check the salary detail of his or her boss or a level above. And that is precisely what it means here with the simple security property. Then we have the star property, which actually means no write down. And this is to do with the fact that the subject with the top secret clearance cannot write down, which means you do not want to have the information being muddled from top down, uh, where, for instance, uh, there is no clarity, or where, for instance, the level of information that is required uh, to understand a given data does not exist. So, for instance, a top boss in a company or a CEO probably will not know what's happening in a business application down uh, 4 or 5 levels his profile, his or her job profile. That is why a, a, a CEO or a senior business manager should not then end up writing data or modeling data where he or she doesn't have that appropriate understanding of it. That is what the star property means. Then we also have a strong property, strong star property, which is like a discretionary security aspect. It entails no read up or right, up and down. Again, what it says is that subjects should only have access to the data at their own level, and it is achieved by, how do you say, by building access matrices where we say that, okay, if you are on a level this, you can read the file that you have created, you can read the file where you have been given access, but you will not be able to read file where you have not been given access, either down your profile or up your profile. Important to note that this model does not consider integrity as an aspect to protect, And it also doesn't cover covert channel operations, for example, bypassing the security clearance and then reading something. That is something will not be covered or will not be protected by this model. It may so happen that a trusted subject will be given access higher to his or her level of what the person can read, but that is only depend if the person has been approved to be trusted and has shown the trust to be able to handle the information which is above his or her access limit. So that is in nutshell what is the Bell-LaPadula model does. And as I said, this can get very confusing. So please pay great attention to different properties. What does mean? Because in the exam, they sometimes test you on those properties by their name, which means you need to remember what the property actually means and what it does. Another model which is important is called Biba Integrity Model, and as the name suggests, this model is to maintain the integrity of the data. Again, this is also managed through mandatory access control, and it has two important properties. One is called the simple integrity axiom, which means no read down. And by read here means not a capability to read and manipulate the data. The simple reason being that integrity is the purpose here. So we don't want to have a wrong or lacking low clearance level data confuse the user. The other aspect, the other property is what you call as a star integrity axiom, and it actually means no write up. Again, the purpose here is that the information which not supposed to be muddled from the level from which it is originating, you would want to tackle that information in the same level and does not allow it to write up. You can imagine, for instance, that the chief financial officer of an organization is submitting a regulatory report. What if the lower levels or the managers below him or her start muddling with the financial data which the CFO needs to sign? That data will lose the integrity and can have consequences. So that's why this information flow model makes sure that the integrity of the upper level data for which the user do not have access is not muddled by the user. So these are the two important models, very important. I cannot stress enough that you have to be absolutely clear with the idea of what it is. It has to be crystal clear and not being confused with the properties in each other. Sometime in exam, they may throw a question which test you both the confidentiality and integrity model in one question. So be very careful when you attempt such a question on information flow model. With that, I'll stop here. Thanks for listening, and I hope to see you in the next session. Thank you very much.